Dear students, I have the pleasure to meet you today to introduce a new branch in Applied Mathematics 2, which is dynamics. And the first lesson in dynamics is momentum. So let's go to this definition. If a body of mass m rates at a certain by velocity v, then its momentum is the vector m defined by h equals mv. So the algebraic measure of the momentum is given by h equal mv. Now, change in momentum. What is the meaning of change in momentum? If the velocity of the body is changed from v1 to v2, then the change in momentum is defined by delta h, where delta h equals m times v2 minus v1. So, when dealing with the algebraic change in momentum, we refer to a unit vector k as the positive direction to the measure of the magnitudes of the velocities v1 and v2. Let's go to example number 1. The ball hits the ceiling and bounces down. If the change in momentum due to impact is 63 times 10 power 3 gram centimeter per second, find the velocity of bounce. Solution. The given is 560 centimeter per second, g, which is the gravity, equals 980 centimeter per second square, and s, the distance, equals 120 centimeter, and the mass equals 150 gram, and delta h equals 63,000 gram centimeter per second, and the required is v2. As you see in the figure, the body is projected upwards at a distance 120 centimeter with velocity v1, rebound the ceiling and let it go down. During the trip upwards, using v1 squared equals u squared plus 2gs, we get v1 squared equals 560 all squared minus 2 times 980, which is g, and s equals 120. After simplifying this expression, we get v1 equals 280 centimeter per second. But during the trip downwards, using delta h equals m times v2 minus v1, and delta h equals 63,000 equals 150 times v2 minus v1, which is negative 280, close the bracket, then V2 equals 140 centimeter per second. Now let's go to a new example. An anti-tank gun fired a bomb of mass 2 kg with a speed of 360 meters per second in direction of a tank moving with a speed of 54 km per hour to destroy it. Find the absolute momentum of the bomb with respect to the tank if: number 1, if the tank is moving away from the gun; number 2, if the tank is moving towards the gun. Solution. The absolute momentum equals mv equals m equals 2, v equals 360. 2 by 360 is 720 kilogram meter per second. The relative momentum. When the tank is moving away from the gun, then VBT equals VB minus VT equals 360 minus 15 equals 345 meter per second. Momentum equals 2 times 345, because momentum equal mv, then the result is 690 kilogram meter per second. Number 2, when the tank is moving downward or towards the gun, so VBT equals VB minus negative VT, because it is in the opposite direction, equals 360 plus 15 equals 375 meter per second. So momentum equals 2 by 375 equals 750 kilogram meter per second. Now let's go to a new example. A car was rating with 72 km per hour when the driver noticed the traffic signal, which is 240 meters apart from him, is red. If the signal was designed to operate red for 15 seconds and the driver wants to cross the road just when the signal turns green, find: number 1, the declaration of the car till the traffic; number 2, the momentum of the car when crossing the traffic. Now, given that the mass of the car is 7.5 tons, solution. As you see in the graph, you see a car apart from the traffic 240 meters, and the traffic is red, yellow, and green. Then, given u equals 20 meters per second and SC equal 240 meters and t equal 15 seconds, then the required is A and V. Using the rule S equal ut plus half at squared, therefore 240 equals 20 times t equal 15 plus half times a times t squared, يعني 15 squared equal 225. Then after calculation we get a equals negative 5 over 18 meter per second square. So v equal u plus at equals 20 minus 5 over 18 times 15 equals 95 over 6 meter per second. And momentum equals mv equals 7,500 times 95 over 6 equals 1187.50 kilogram meter per second. Everybody will remain at rest or continue to move with uniform velocity unless affected by an external force. This rule become the law suggests only two states for bodies. Number A, the state of rest. Number B, the state of uniform motion in constant direction. But number two is the law supposes that any body have no self-ability to change its state, and this is known as inertia. Number three, the law supposes that only external force has the ability to change the state of the body. And we mean here by the force the resultant of external forces affects the motion of the body. From this we see that it equates between the states of rest and uniform motion from the point of view, that in each case the forces are in equilibrium. Now, results of the first law. Number one, when the body is in either the two cases, rest or uniform motion, the resultant of the forces affects it vanishes, so we can write sum of forces in direction of motion equals sum of forces anti-direction of motion. Otherwise, the body will accelerate it. Number two, the law defines the force by force in each effect changes or tends to change the state of the body from rest or uniform motion in straight line. Let's go to an example. The diagram shows the forces that are acting on a particle. Has the particle an acceleration? As you see in the figure, three forces of magnitude 4 Newton, 4 Newton, and 6 Newton. The angle between every two forces is 120 degrees. Analyzing forces in the horizontal and vertical directions, we get 4 cosine 30 minus 4 cosine 30 equals 0. This is in horizontal level, but in the vertical component, 4 sine 30 plus 4 sine 30 minus 6 equals negative 2. Therefore, the resultant is not 0, so the particle has an acceleration. Now let's go to another example. A body is pulled by a force of magnitude 910 kilogram weight, inclined on the horizontal by an angle theta, where sine theta equals 5 over 13. If the body moves uniformly on the road and the resistance of the road equals 2 over 3 the weight, find the weight of the body. Dear students, let's go to solution. As you see in the figure, we draw a right angle triangle and sine theta equals 5 over 13, cosine theta 12 over 13, tan theta 5 over 12, and we put a body on a horizontal level, so its weight is W downwards, and 920 is resolved or factorized into two components, up 910 sine theta and horizontally 910 cosine theta, and to the right we draw 2 over 3 W and vertically N. Since the body moves uniformly, then R equals 0. Therefore, 910 cosine theta equals 2 over 3 W, the horizontal level. So 920 times cosine theta 12 over 13 equals 2 over 3 W. Then W equals 1260 kilogram weight. But vertically we can write 910 sine theta plus 10, the two forces upwards, equals W, the weight of the body, downwards. Then 910 times sine theta, which is 5 over 13, plus N equals W, which is 1260, and after simplifying we get N equals 710 kilogram weight. Now, dear students, let's go to a new example. An express of mass 160 tons moves on a horizontal rail if the resistance of the rail is directly proportional to the square of its velocity, and the maximum force of the engine is 7,200 kilogram weight, and its maximum speed is 90 kilometers per hour. Find the resistance per ton when its speed becomes 30 kilometers per hour. Solution. Since R varies as V squared, therefore R1 over R2 equals V1 squared over V2 squared, and this is a rule for variation you studied before at first secondary. Then as you know طبعا V2 is the maximum velocity, but at maximum velocity the train will move with a force 7,200 to the right, and the resistance to the left is R2. Then R2 equals the force of the engine, which is 7,200. Then R1 over 7,200 equals 30 squared over 90 squared. Therefore R1 equals 7,200 over 9 equals 800 kilogram weight. Then the resistance per ton equals 800 over 160, which is 5 kilogram weight. Now, dear students, let's go to another example. A parachutist falls with his parachute downwards. If the resistance of air is in proportion with the square of his velocity, and this resistance is half the weight of the man and his parachute when the velocity is 10 kilometers per hour, find the maximum velocity with which the parachutist can move. Solution. Since r varies as v squared, therefore r1 over r2 equals v1 squared over v2 squared, where v2 is the maximum velocity. But at maximum velocity, as you see in the figure, the weight of the man and the parachute is downwards, but R2 is upwards. Then R2 equals the weight of the man and his parachute equals W. Then half W over W equals 10 squared over V2 squared. Therefore, half V2 squared equals 100. Therefore, V2 squared or V2 squared, yes, equals 10 root 2 kilometer per hour. A body moves uniformly under the effect of 4 coplanar forces, F1, F2, and F3, and F4, where F1 equals 3J, F2 equals 3I minus 2J, and F3 equals I plus 3J. Find F4. Then find its magnitude and direction. Solution. Now, since the body moves uniformly, then R equals 0. Therefore, F1 plus F2 plus F3 plus F4 equals 0. Then F1 plus F2 plus F3, which is 3J plus 3I minus 2I plus I plus 3J plus F4, which is unknown, equals 0. Therefore, F4 equals negative 4I minus 4J. Then the absolute value of f4 equals square root 4 root 2. And here tan theta equals therefore measure of angle theta equals 225, not 45, because y and x are both negative. Then theta lies in the third quad, which is 180 plus 45 equals 225. Dear students, this example leads us to the end of our program today, and until we meet again the next week at the same time, I hope you enjoy our lesson today. I hope you all success. Thank you and goodbye.